in linked list, we are going to see singly linked list in deep in this today's session. Okay. So first of all, I want to go through with the previous topic, what is meant by data structure. Then we will revise with the primary topic. Then we will discuss deeply into the singly linked list topic. So what is meant by data structure? So we know a data structure, data plus structure. What means we are organizing the data, we are storing the data, and whenever we want, we are retrieving the data. Okay, so this is about data structure, and we are showing the relationship with each other. So definition of data structure is like a way of organizing, storing, retrieving the data and the relationship with each other. So data structures are used in operating system, compiler design, statistical and numerical analysis, database management system, expert system, network analysis. So these are the applications of data structure. So how this data structure is classified means data structure is classified into two types. One is primitive data structure and another one is non-primitive data structure. So primitive data structure in the sense all the primary data type like int, char, float, all those things will be coming under the primitive data structure. Then what about the non-primitive data structure? Here again it is divided into two types. One is linear data structure and another one is non-linear data structure. So under linear data structure, array, stack, queue, all those things will be coming. Under non-linear data structure, graph tree like this, it will come. So this is a basic classification of data structure. So primitive data structure in the sense, it is a basic data structure which can be directly operated by the machine instruction. And non-primitive data structure in the sense, it is the data structure which emphasize on structuring of a group of homogeneous or heterogeneous data item. So it is again classified into two types. One is linear data structure and another one is non-linear data structure. Linear data structure is nothing but it is a data structure which contains a linear arrangement of elements in a memory. And non-linear data structure, it is nothing but the data structure which represents a hierarchical arrangement of elements. So this is about the types of linear and non-linear data structure. So abstract data type, what is meant by abstract data type? These are the primary terms what we know, what we need to know before going to this linked list. Okay. So abstract data types are mathematical model of a set of data values or information that shares similar behavior or qualities that can be specified and identified independent of a specific implementation. We will say as ADT. It is normally used in algorithm. So the data items or its associated operations we will be defining rather than its implementation. So ADT is nothing but what a set of operations that are written once in a program and can be used anytime from any part of the program. So this is about ADT. So what are the benefits of using ADT means it achieves the modularity. So modularity in the sense each data type can be considered independently and it can be used in testing and division of labor and reusability concept it achieves, and the change of implementation can be easily done with no effects to the user. Okay, so list ADT in the sense what now? A list is nothing but a linear data structure. So it is a collection of elements. In general, the list is in the forms of elements like A1, A2 till AN. So where N is the size of the list associated with the set of operations listed below. Okay, so like insert, delete, find, print list, make empty, all those operations, all those things we can do using this list ADT. If I want to insert an element now, I can easily insert the element at the position. I want to insert the element X in fifth position means it will be inserting the element in the fifth position. Okay. So delete in the sense if I want to delete the element, I can delete the element directly by calling the function delete of X. If I want to search an element, I can do it using the find function. So print the list for displaying all the elements from a list, and make empty where make the list as empty list. So all those things we can do using yeah, under this list editing. So next is what now methods to implement a list. Okay, so there are two ways to implement a list. So one is array implementation of list, and another one is linked list implementation of list. Okay, so what is meant by array implementation of list? We are just array is nothing but what we are just it is a static data structure where the memory should be allocated in advance. Okay, the size will be fixed. So how many elements I want, I can add over here. Okay, so this is about what array implementation of list. Okay, so size fix pannitana, I cannot add more elements beyond that size. Okay, so that is one disadvantage of this array. So what are the basic operations we can have on this list of elements? And I can create, I can insert the element in a particular list. I can delete the element in a list. I can display all the elements in a list. If I want to find any particular element in the list, that I can find using the search function. So all those things I can do in this array implementation of list. So create, okay, so create operations where initially the array size is fixed. Okay, so I can um, by getting the number of elements, okay, in the scanf, that value will be stored in n. Next, one by one, using this for loop, I am getting the element that will be stored in the address of list of 0, list of 1, list of 2. Maximum size I have given like n. So if I am giving the n size like 5 means till list of 4, it will be getting the element. So next, insert operation. Insert operation in the sense what it is used to insert a element at particular position in a list. So inserting the element in the last position of an array is very easy. Okay, I can insert directly. But inserting an element at a particular position in an array is quite difficult, since it involves all the data from the specified position to be moved from one position right in an array. For example, see here the maximum elements I have given like 10. So 0 to 9. Okay, I can insert the element in the index 0, 1, 2, 3, 4 like that. So here I have inserted with the 5 elements. So till index 4, I am just inserting the element 10, 20, 30, 40, 50 like that. Right. So if data 15 is to be inserted in the first index, okay, I want to insert the element 15 in the first index means what I'm doing in the array implementation of list, I'm just moving remaining elements to the next position. Okay, I'm for example, here I want to insert the element 15 in the position 2, that is in the index 1 means first I'm just moving this 50 to the next position. This will come in the fifth index, and this 40 will come in the fourth index. This 30 will come in the third index, and this 20 will come in the second index. Making like this, moving one index again, I'm just emptying this position. Then only I can insert this 15 directly to the index 1, that is to the position 2. Okay. So this is the program for inserting the element. So here I have declared with a variable. Next, I'm just entering the data to be inserted. Okay. What element I want to insert, I'm just getting that, and that will be stored in the address of data. Next, again, I'm just entering the position at which element to be inserted. Okay. So here the position, I'm entering 2 or 3, that will be stored in the address of push. And using the for loop, I'm just getting the element one by one. So first list of 0, what element it will be stored. Next, here I'm just moving. Okay, I'm moving other element to the next position. For that only I'm using this for loop. In previous case, I told no. this 20 will be moved to the 30 position, that is 30 element, the element position. So like that, we are shifting one position ahead. So that only done using this for loop. Okay. So one by one, this element will be what? Moved and making this position empty. And after this position get empty, the data 15 is the data, right? So it will be stored in the list of post minus 1. Post minus 1 means what? The position, if I have given 2 means 2 minus 1. So list of 1 la, I'm just initializing the data 15. So here what happens? In list of 1, this 15 value will be what? Stored. So this only I'm doing over here. Okay. Next, I'm just incrementing that n value, and I'm just calling this a display function to display all the elements. So next operation is what? Deletion. Similar way, if I want to delete one element from an array means I can delete the element easily, but that position will be empty. So what I will do, I will first move one element in left side. Okay. So this fifth index element will be moved to fourth index. If I want to delete the first index element, what I will do, fifth index element will be moved to fourth index, and fourth index element will be moved to third index, and third index element will be moved to second index, and second index element will be moved to first index. Okay, if like this, if I'm just doing, what happens, this 15 value will be deleted automatically. After the fourth data movement, this 15 is deleted from the index 1 of the array. That is only happening. Right? So this is delete operation function. Okay. What I have done, so I'm just moving this I plus 1 position to I. And again calling the display function. Okay. One by one using this for loop, all the elements in an array will be what? Printed. And if I want to search the element also, I want to search one by one. Okay, here I'm getting the search element that will be stored in the search. So here using the for loop, I'm just checking whether my search element is equal to that list of 5. Okay, so like that one by one, I'm just checking if that element is there means I'm just incrementing the count. Previously, I have initialized the count as 0. Okay, so here I'm just incrementing the count. And after incrementing the count, if the count value is 0 means element not present. Else means element is present. Okay, so like this I will be doing in the search operation. Okay, so this is about what? Array implementation of list. Okay, so now in array, I'm just fixing the size and I'm storing the element one by one. If I want to insert the element also, I need to move remaining element to in the one position. I need to move, and then only I need to free that space in that particular position. Then only I can insert the element. So that is only possible in array. Okay, so if I'm just initializing, if I'm just having the size as 25 means, but I'm just giving 25 size, but I'm just giving inserting only a 10 element, now 15 element size is wasted. Okay, but using this linked list is nothing but what? Linked list is a linear data structure, and nodes make up this linked list. And nodes are structure made up of data and a pointer to another node. Okay, and usually the pointer is called the next. So see here in the single node, I am having the two field. One field is to store the data, and next field is to store the address of the next node. Okay, for that I am using this linked list. So linked list la I am having the nodes. Okay, nodes only will be making the linked list. So in linked list, where I'll be having the data. To store the data, I'll be having one field, and to store the address, I'll be having the another field. So if I want to store the address, means surely it should be of what? It should be of pointer variable. Then only it stores the address. Okay. Okay. So what is the difference between this array and linked list? So array in the sense it is fixed size, and resizing is very expensive. But in case of linked list, it is dynamic size. Okay, during the execution time only, I can enter the elements. Okay, how many elements I want, I can enter those elements, right? So in array, insertion and deletion are inefficient, because for inserting the element, what I'm doing, I'm just shifting one element again, then only I could able to insert the element. So elements are usually shifted. In linked list, insertion and deletions are efficient, no shifting operation. No shifting operation. Directly we are deleting and we are linking one node with another. We will see the process. Okay. So next third point in array, random access, that is efficient indexing. And a linked list, no random access, not suitable for operation requiring the accessing element by index, such as sorting. In array, no memory waste. If array is full or at most full, otherwise may result in much memory waste. In linked list, since memory is allocated dynamically during the execution time only, if I'm just inserting with one element, it will be allocating the memory. Right. So here the memory is allocated dynamically. There is no waste of memory over here in case of linked list. In array, sequential access is faster. The reason is what? Elements is contiguous memory location. But here the sequential access is slow only in linked list, because the reason is what? Elements are not in contiguous memory location. So this is the major difference between array and linked list. This is the need why we are going for the linked list instead of the array. Okay. Then what are the types of linked list? We having singly linked list, we having doubly linked list, we having circular linked list. In circular linked list, we can have circular singly linked list and circular doubly linked list. So like that we can have. Okay. So today's topic we are going to see singly linked list. Okay. So singly linked list means what? I told linked list will be a collection of nodes, right? So here in singly linked list, each node has only one link path. Okay, one link path means what? Each node will have two fields. One field is to store the data and another field is to store the address of the next node. Okay, so each link path contains the address of the next node in the list. The link part of the last node will contain what? What address? It contains a null value, because it is the last node. No, so next node address it will not have. So the address field of one node is null, means it indicates that it is the last node. Okay, which signifies that we are coming to the end of the node. Okay, so this is about what? Singly linked list. So see here, I'm having the data item. Okay, see this one is a node which is having two field. One is what? Data. To store the data, I'm having the field data item field, and to store the address, I'm having the next field. So see here in this diagram how it is connected. So we having here in this diagram three nodes, right? So data items are 10, 20, 30, like this. In each node the value will be stored. But how this node will be connected to the another node? Using the address only it will be connected. Right. So if I'm having the address for the second node, I'm having the address like 2000. In the first node, the next field, I will be having the address 2000, which means that first node is connected to the second node. Okay. So if I'm having the third node address is 3000 means next field of second node will contain the value 3000. Last is the last node. So in last node, the next field value will be what? It is null. Okay, next field value is what? It is null. So null means what? It indicates we are coming to the end of the list. That is the last node. So we are indicating like this. So linked list can be visualized as a chain of nodes where every node will be pointing to the next node. So singly linked list, in this type of linked list, two successive nodes are linked together in linear fashion. Okay, if I'm having two nodes, that will be what? Link in a sequential manner. So each node contains the address of the next node. So in singly linked list, only linear or forward sequential movement can be possible. So elements are accessed sequentially, no direct access is allowed. Okay. So here in each node, I'll be having two field. One is to store the data and another is to store the address. That field we are telling as a link or next. So here in linked list, what are the operations I can perform? I can do insertion. I can do deletion. I can do display. I can do search. I can delete. All those things is possible. Insertion, I can add the element at the beginning of the list. Or if I want to add the element at the end of the list or to a particular portion, that is also possible using the linked list. Deletion, I can delete the elements in the beginning or to the end or to any portion, that I can do it. Display, I can display the complete list of elements. Next, if I want to search element in a list, yeah, we can search using the particular element. It will be searching whether this particular first element is equal to this, like that it will be searching. Okay, so searching is possible. If I want to delete an element, oh yes, I can do it. Okay, using a given key, I can do it. So that deletion also is possible. So these are the basic operations we are performing under the singly linked list. Okay, so see here. So here I'm in the first node, I'm having the address like 900. Next node la 1000. Next node 2000. Next node 3000. Next node 4000. Right. So here this type of questions will be coming in gate. Okay, so if this node is connected to this node means what is the address of this node? Or they will give the questions like creating the node, inserting the list in the linked list we are seeing, no? So they will be deleting one line and they will be asking you to find what is that line. Okay, so all those things is possible. Okay, so see here in the declaration of the linked list, I'm just declaring with this 5 parts. So void insert, where I'm just giving a passing three argument x, l, and the position p, and to find the element in the list using the find function, I'm just doing it. Okay, where I'm just passing again two parameter. One is entire list, and then what element I want to search that element. And if I want to delete again, okay, what element I want to delete, in what list I want to delete. So I'm just passing the element and then the list. So next I'm just declaring with the struct. So type dash struct node asterisk position. The meaning is what? Instead of struct node, I'm just giving the name position. So in position, I'm just including all the variable LP, new node, temp, everything. So this is about the declaration of the linked list. So see here, I'm having the node. I'm having the address like 900. Next node, I'm having the address 1000. Next 2000, 3000, 4000 like that. So second node address 1000. First node order. Next field or in address field, I'm having that 1000. Then only this node will be linked to the next. Third node address is 2000. So that address I am having in the link field or address field of the second node. Then only second node will be linked to the third node. So like that, it will get connected. By having the address only, one node will be connected to the another node. So lastly, what happens? I don't have any address, which means we are coming to the end of the node, right? So this is about this like this only we will create the list. So if I want to create the list, I want to give the structure. So see the node structure for singly linked list, struct the structure name. The structure name is what? Node. So in each node, I am having two fields, as I told previously, data and the address field. So data and a normal data. So I'm just declaring in the int data, like that I'm just declaring. Next, I am just want to store the address, right? So if I want to store the address means which variable will be storing the address? Pointer variable only will be storing the address, right? So that pointer I'm just declaring position asterisk next. The meaning is what? Struct node asterisk. I'm just instead of struct node asterisk, I can give position. That only using the type def I have already declared. Okay, so that only I'm having here. Position asterisk next. This next will store the address of the next node. Okay. So how to create a linked list? So how to create a linked list? First, I'm just creating with a create function. So here I'm just declaring with a variable int I comma n. Next, the header, okay, starting pointer. So I'm just having the starting pointer. So like L, I'm just declaring with null. Okay, so linked list what dynamically it will allocate the memory, right? So I'm just giving new node equal to struct node asterisk malloc memory allocation. Okay, so what size I need to give? Size of struct node. So what is the size of struct node for data which is of type int up to 2 bytes? If it is 64-bit, 4 bytes. Okay, plus this address field, it will be normally of 4 bytes, so 8 bytes. So 8-byte memory will be allocated. Okay, for this new node variable. So next I need to enter how many nodes I need to insert. That number of nodes I need to enter, 5 or 6 are that number of nodes. Next I need to enter the data. One by one, I need to enter the data. Okay, 10, 20, 30, 40, like that. So it will be stored in the address of new node of data. Next, I need to, firstly, in the new node, the address field does not contains any address, right? So new node of data, you should read this arrow markers of new node of data. Okay, which field is new node of data? New node of next. This one. If I'm having 10, 2000 means meaning is what? 10 is the data field. So new node of data. I'm just storing this 10. Initially new node of next, I'm just initializing as what? Null. Okay. So next L equal to new node. L equal to new node means what? Using the starting pointer, I'm going to move. So L equal to new node, first node will be what? Our new node. So next P equal to L, again the first node will be what? That P. So using the for loop, one by one, I'm going to get the data. So 5 elements I want to insert means first element already inserted. So I want to insert with the second element. So second element till the n. Till less than n means what? 5 element, na? Okay, so 5 element in the sense what? I need to insert with the 5 element. Already one element is over. So I equal to 2. Okay, so new node again it is will be creating the memory allocation using this malloc function. Again it will be entering with the data, and again p of next equal to new node. So p of next equal to new node in the sense what? What is p of next? This one is p of next. So this is another node means p of next equal to new node means what? this address, this will be connected to this one. If I want to connect this to this one, means what? This address will be stored over here. Okay. So this is about the this creating the nodes in a linked list. So what is a routine to insert an element in a list? So adding a new node in a linked list is a more than one step activity. So we can learn this with our diagrams here. Okay, so normally we are creating the node where this is the pointer, starting pointer, where I am having the nodes which will be having the two field. One is the data item, another one is the address field. Okay, so like this I'm having two nodes. Okay, having the data field and the address field. Now what I need to do means I need to insert another node. Okay, this new node. So what I will do here, this next field I need to connect to this data item, and this new node address should be given to this first node. Then only this node will be connected to this new node and new node will be connected to this last node. Okay, this is how we can insert a element in a list. Okay, so see here what they are doing. Instead of having like this, first I'm just connecting this next field of new node with the last node. And this first node, the next field, I'm just connecting with this new node. If I'm like in the new elements. Okay. So see here, insert an element in a list. For this, we uh, have the program. So first, I'm just declaring with the variable ch. Okay. So first, enter your choice where I need to insert the element. Whether in the first part I need to insert the element, whether in the middle part I want to insert the element, whether in the last part I want to insert the element, I need to choose that choice, 1, 2, or 3. I need to give that. So that will be stored in the address of ch. Next, using the switch case, I'm doing one by one. Okay. So switch off 1. So switch off 1 in the sense what? Our case. So case 1 in the sense P equal to L. That is our starting pointer, and then I'm creating the new node. First I'm just entering with the data to be inserted, so that will be stored in the new node of data. Next, new node of next, I'm just connecting with the starting pointer, so new node of next equal to our L header. Next, L equal to new node, so that header will be connected with this new node. Next, display. Okay, entire elements will be what? Display. So this is if I want to insert an element in the first beginning, means this program part. Okay, this program part and all you need to understand. In your question, they will be asking by giving inserting the element at the beginning. They will be giving the set of question and they will be asking you to find which coding line is missing. Like that and all, you will be getting the question in the gate. So you need to clearly understand with this part. Okay. So next is your case 2 part. So in case 2 part, again, I'm just entering the position and I'm just initializing with the I value. Next, declaring P equal to L and new node equal to struct node asterisk malloc of size of struct node, which means what? Again, I'm creating the new node and what data to be inserted. The data I'm just giving over here. That will be stored in the new node of data. Okay, next enter the position to be inserted. That position I'm just giving over here. Okay, what position I need to insert this element, that position. Next new node of next I'm just having like what? Null. So one by one I'm going to move and I'm going to insert the element in that particular position. So that is achieved using this while. So first I value is what? 1. If I want to insert the element at the position 2, I less than 2 minus 1, which means 1 less than 1, condition false. So it will be coming to this part. So new node of next, I'm just initializing with P of next. Okay, so new node of next is what? Our new element, that next part. So P of next in the sense what our element, our position. I'm just moving that header position, no? So that position. So it will be linking that new node of next to that particular position. Next P of next equal to new node. Then displaying all the list of elements. Similar way for end. End only this two condition varies. What means I need to find, because if it is coming to the last node, directly I can insert the element in the last node. So what condition, if it is last node means what condition I'll be checking? The last node address field should be what? Null, right? So I need to check P of next should not be equal to null. If it is not equal to null, in the sense I need to move the pointer to the next position. Okay, so using that I'm having this condition while of P of next not equal to null. So in this, I'm just using this P equal to P of next. I'm just moving 111 position ahead. So this is about inserting the element at the last node in the list. So to check whether a list is empty or not, what condition I need to give means L of next is equal to null, means the pointer, the beginning pointer is null, means what? The entire list is empty. If it is not null means I'll be having some address, which means some element is there. So the list is not empty. So to check whether the current position is last in the list, I can check using what? P of next equal to null, where I need to have the position and I need to have the list. So like this, I can check whether the current position is the last in a list. So if I want to find the element in a list, okay, to find the element in a list, I need to search the element. Yes, so I need to search the element using find. So search and count equal to 0. I'm just initializing the value 0 to the variable count. Next, I need to search. I need to get the element. Which element I need to find? Okay, so I'm just getting that. That will be stored in the variable search. So in the beginning, P equal to L. So which means that it is the starting pointer, right? So first P should not be equal to null. P should not be equal to null in the sense what? Some element is present in that list. Okay. So each data I need to check with the search element. So if P of data equal to the search element means I'm just incrementing that count and just coming out using this break. And then I'm just moving the pointer to the next, means I need to give P equal to P of next. Like that I can move to the next pointer where I can search the element, right? Next, if count equal to 0 means element not present. Else means what? Element present in a list. Okay, so this is how I can find a element in a list. Okay, so see here, this is a starting pointer. So here, so see here, this is a starting pointer, and here the elements I'm just inserting, and each element I'm checking over here. Whether that search element X is equal to 10, whether that search element X equal to 40, whether that X element is equal to 20. Like that I'm checking. When it reaches that 20, that search element, I'm just telling this element is present. Okay, so this is how I'm just doing this search operation. So if I want to find the previous node, I want to return the position of the predecessor. So how I can do that? So previous node in the sense I need to enter the position. Okay, next the pointer. Next I need to check whether the P of text not equal to null. And another thing, for what data position, the previous node I need to check. I need to check whether the data is not present. So P of next means that particular address field of data means the next field data. So it should not be equal to what the particular data what I am trying to search. If this two condition is true means it is coming inside this while where it is moving to the next node. So like this I keep on searching and I am just finding the returning the position of the predecessor of the element what I am just inserting. So next is about to count the element in a list. In the sense I am just counting the element. So where the element should be present. Okay, so P of P equal to null means what? At one node, the address field will be what? 0. Address in the sense not 0. It does not contains any address. Okay, so that will be reaching the last node. So I'll be checking here P of not equal to null over here. So like this, I'm just incrementing the count. Okay. So next, using this P of next, I'm just moving to the next node. So after that, when this condition get false, I'm just printing the count value. Okay. So like this, I'm just moving. This is a diagrammatical representation. So to delete the element from a list, that is also here. See, I want to delete 20 from a list. So a node with data 20 is found over here. So I need to make a node to be deleted as what na temporary. Which node I want to delete, that node I'm making as what na temporary temp. And I need to update the address part of the previous node from the temp node. And I need to using this free function, I need to release the memory of the temp node. So how I'm doing over here using this delete function, I'm just declaring with this position that is struct node asterisk. Instead, I am writing this position because I need to declare this p and temp of pointer variable. I'm doing like this, and axis of integer data type. I'm just initializing p equal to n, checking whether p equal to null, which means the list is empty. Else means I need to enter the data what I want to delete. So that will be stored in X. Next, I'm just checking what data I want to delete is equal to p of data, which means it will be checking from the first node till the end. Okay, so if this data is equal means what happens means I'm just initializing that p equal to what? That will be placed in the temp. So temp equal to p. Next, I'm just moving that L pointer to p of next. So it will be searching one by one, one by one. In one case, what happens? That particular data will be equal to the data what I want to delete. So in that case, in which part p is there, that node will be considered as a temp. And P of next means it will be pointing the next node, right? So that will be connected, that L will be connected to that P of next, and I'll be freeing this temp, temp node. Okay, then I will be calling this display function, and all the data in the list will be what? Printed. So this is how I can delete the element from a list. So this is a diagrammatic representation I have shown here. So a node which contains the data items and the next field, like creation of the node. This is first diagram. Next, if I want to delete means I'm just a target node that I want to delete, right? So I need to have this p of next to be pointed to this node, and this target node will be stored in temp. And using the free, I'm just deleting this target node address. Okay. So to delete an entire list, I'm just checking p not equal to null, and then I'm just freeing the entire list free of p. So to find next element in the list, what I'm just doing, while p of p not equal to null and p of data not equal to x, I'm just checking one by one. I'm just moving, and then I'm just returning the address which I want to delete. Okay. So application of linked list, I can use this linked list which is applicable in following areas: polynomial manipulation, multi-list set operation, radix sort, dynamic memory management. Okay, so like this and all, they can ask the questions. So polynomial manipulation like addition, subtraction, differentiation, etc. can be performed using this linked list. And declaration of linked list implementation of polynomial ADT, like here in polynomial addition or subtraction, I'll be having three field where one is to store the coefficient, I'll be having the coefficient field, and to store the power, I'll be having the power field, and to store the address of the next node, I'll be having the next field. Okay, so I'll be having three things over here under this struct. Okay, so under struct, the poly is a structure name. So I'm declaring all the variable over here, and using the pointer only I can move. No, so here I'm just giving with the three pointer, list one, list two, list three. Okay, so see here list one, where each node I'm having two field. What is that field? Coefficient and then power. So here the coefficient is 5, the power is 2. Coefficient is 4, power is 1. Coefficient is 2, power is 0. So this is one polynomial. This is another polynomial list which is having coefficient 5, power is 1, and again coefficient 5, power is 0. So which power matches 1 1 now, this value will be added. Here the power 0 matches. So this coefficient 5 plus 2 will be added. So the resultant list will be what? 5 coefficient and 2, that is a power. 9 coefficient, 1 is a power. 7 coefficient, 0 is a power. So here the node structure in this polynomial, first the coefficient, next the power, next the address of the next node. Like this I need to write the program. So here in this creating the node, that only we have given. So we are entering the coefficient value and we are entering the power value. Next, in the next field, I'm just creating with the address field, and then I'm just creating with the new node. Okay. So till how many nodes I want, I'm just creating one by one. So that one node will be linked with the another node. So for addition of two polynomial, what I'm doing, here pointer 1, ptr1, which is having the list 1, ptr2, which is having the list 2. Here I need to check that ptr1 and ptr2 should not be null. Okay, then next I need to create a new node. Next I need to check the power. Okay, ptr1 power should be equal to ptr power 2 means I can add the relevant coefficient. Okay, and I can give the result. Okay, so like this I can do. So this is possible in this addition of two polynomials. So see here, this is the main function. So I'm just creating the polynomial using create function, and then displaying the polynomial using show function, and I'm adding the polynomial using polyadd function. So here the following function reverse. This is actually one question. So what is the following function reverse is supposed to reverse a singly linked list. There is one line missing at the end of the function, what we need to find. Okay, so here in this program they have given like what structure node. Inside that they have declared with two variable. One is what normal data, to store the normal data they having. Next, to store the address field, I'm having struct node asterisk next. Okay, so headref is a double pointer which points to the head of the linked list, right? So static void reverse, in this function I'm just giving the node and the href. So here previous node I'm just initializing null, and current I'm just giving the headref. So current not equal to null means it is coming here. So next field it is just adding the current of next. Okay, so what is the statement here we need to have? So this is a question. So what should be added in place of add a statement here? That is this line. What we need to have. Okay, so that function correctly reverses a linked list. So what should be add? Asterisk headref equal to previous, or asterisk headref equal to current, or asterisk headref equal to next, or asterisk headref equal to null. So what value I need to have? The answer is what? Asterisk href equal to previous, that is prev. So at the end of while loop, the prev pointer points to the last node of original linked list. So we need to change asterisk href so that the head pointer now starts pointing to the last node. So this will be the answer. Okay. So what are the topics we saw? What are the things we saw in today's class? So we saw what is meant by linked list, why we need to go for linked list, and what are the operations are there in linked list, how we can do, how we can create using the program, and we saw the application of linked list, and then we saw the question based on that singly linked list. Okay, so far we have covered this singly linked list. Okay, so in singly linked list we'll be having a single node which contains two fields. One is the data field and another one is the next field which shows the address of the next node. Okay, so like this each node will be connected to the other nodes. Okay, so in next session we will see doubly linked list. Okay, and circular linked list, and we will cover the questions based on Gate. Okay, so with this I will end today's class. Thank you everyone.